Hi everyone. In today's video, we are going to go over the answer key for problem set 3. This problem set really revolved around chapter 3, which is the idea of measures of central tendency. So primarily the mean, median, and mode, as well as discussions about skew, whether it's positive, negative, or symmetrical in nature. And so with that being said, let's start off with question number 1. The St. Louis Police Department collected a random sample of citizens from the St. Louis area to examine how many traffic citations each person has received. Using the table below, calculate the mean, median, and mode. Let's start off with our mean. And so the formula to calculate the mean or the average is to add together all of the values from the sample and divide by n, which is the number of observations you have within your sample. And so you can see here that I work out the math by adding together all of the numbers of citations that we have in our table here and dividing that by 10 because there are 10 individuals within this sample. And so if I take the total number of citations, which is 37, and divide that by 10, I get an average of 3.7 traffic citations. Let's move on to the median. The median is a really good and useful measure of central tendency because it shows us where our 50 percentile marker is within our distribution. And so here, knowing that I have an even number of observations, I know that there are going to be two values that I will need to identify and divide those by 2 in order to identify our median. Because we have 10 observations in this sample, this will be our 5th and 6th observation, both of which in this particular sample happen to be equal to one another, or the value of 3. Again, to identify the median, you first want to start off by ordering all of your values sequentially. So in this case, from lowest to highest. And again, our 5th and 6th observations are 3 citations. So if you wanted to show your work by doing 3 plus 3 divided by 2 to also get 3, that's perfectly fine as well. Either option is acceptable for this problem set. Moving on to the mode. This is a measure that takes a look at what the most frequent observation or value is within a sample. And so using this same sequential ordering that I have here from the median, I brought that down here. And what I'm looking for here is the value that occurs the most times. And so in this example, it is 2 citations. And we have 3 individuals who reported receiving 2 citations. That is Ashley, Kalia, and Natasha. And so there aren't any other values that appear 3 times or more, and so that's why our median is 2. The last component of question 1 revolves around the idea of ratios. This is actually an idea from chapter 2, but I wanted you to apply it in this context as well. And so with ratios, the first thing that we do is identify our first variable of interest and then compare it to our second variable of interest. And so taking a look at this particular question, I see our first variable is the number of citations from female citizens, and we will be comparing that to the number of citations received by male citizens. And so whenever calculating a ratio, you always want to make sure that the first variable of interest is stated first, and the second one is in comparison to that. And so what I did here below is add together all of the number of traffic citations received by our females within our sample. And then I compared that to the total number that males received. And so the most common way to express a ratio is to do this in this format, which is our total from our variable of interest 1, which is 14, then a colon compared to our second variable of interest value, which is 23. And so if you went ahead and actually did the math on this and did 14 divided by 23, you were going to receive a decimal. But when we're using individuals, it's sometimes hard for us to interpret having a certain proportion of individuals, right? It doesn't really make sense. So it's perfectly fine to just state this as whole numbers or 14 colon 23. Moving on to question number 2. If the St. Louis Police Department decided to add one more person to their sample, Nico, who has 18 traffic citations, How does that affect the mean, median, and mode of our original sample? Explain and justify your answer. And so, without even doing the math on this particular problem, you could answer it straight away. Because the main purpose of this question is to show you that the mean is the measure of central tendency that is most influenced by an outlier value. And so, taking a look back up at our table here, I see that the number of citations for our original 10 don't even enter double digits. And so Nico's is definitely stretching that distribution much higher than where the average or median value is in our original sample. If you went ahead and calculated each of these, let's take a look at what this would look like in this example. The mode is the measure of central tendency that is the most resistant to an outlier. Reason being is an outlier is typically a single value. And so if I were to add 18 to this distribution, there isn't another observation that is also equal to the value of 18. And so our mode does not change. It remains 2 because we had 3 individuals who received 2 traffic citations. The median is slightly more influenced by outliers, but not a whole lot, because again, we're dealing with our 50th percentile of our distribution. The main kicker here is that we now have 11 observations rather than 10. And so since we have an odd number of observations within our sample, we are now going to have a singular median value. So whatever is the middle point. In a distribution of 11, that would be our 6th value, which also happens to be 3. And so if we would have had another sample in which all of the observations were different from one another, it doesn't necessarily mean that the median is resistant all of the time. It just so happened in this particular example that both of those middle values in the first example of our 10 individuals were both 3. And now since we're just shifting it one place, our 6th observation remains 3 as well. Once we get to the mean here, though, this is the most influenced by outlier values. And so if you wanted to go ahead and calculate this to see how it affected our mean value, you would add together all of the citations, including Nico's 18 value here, and divide it by 11, because now there are 11 observations within our sample. You would get a total of 55, and you divide that by our n, or 11, to get a value of 5. And so our mean has increased quite a bit because of Nico's citations. And so again, the overall purpose of this question is to show you that the mean is easily influenced by outlier values, while the mode and median tend to be more resistant in these circumstances. Moving on to question number 3. A random sample of 8 houses in St. Louis report the following home values. So we have 8 listed here. Seeing that I have another even number here should trigger to you that our median value is going to be 2 observations that we'll have to divide by 2 to find that 50 percentile mark. And so we'll keep that in mind as we move forward with calculating both our mean and median. Starting off with our mean, same exact procedure you saw in our previous questions. We add together all of the values that are listed there and divide by n. In this case, it is 8 houses within St. Louis to get an average home value of $361,875. Moving on to our median. Again, I mentioned right away that this is something that will have 2 values attached to it because we have an even number in our sample. And so this will be our 4th and 5th observations once we order those sequentially from the lowest value to the highest value. If I add together both of those values and divide by 2, I get a median value of $230,000. Now that we've calculated both of these measures of central tendency, the last component of this question asks, does the mean or median better represent the typical house price in St. Louis? And explain your answer. It would not necessarily be correct to say just on the surface that the median is more representative simply because it emulates more of these home values than the mean. That's not what's happening here. Again, it's the same idea from question 2 that the mean is pulled more by an outlier value with this $1.275 million house compared to all of the lower home values we see within our sample. And so you can see quite the discrepancy between our average value and our median value. And so if you just said that the median is because that's a lower value and that is more typical of St. Louis, that's not the purpose of this question. Again, it's to show you that the median is more resistant to our outlier of the $1.275 million house, where the mean gets pulled. Think back to the example we talked about within the PowerPoint about adding Jeffrey Bezos to a sample. When it comes to net worth overall, if he's within our sample, he's pulling it to the extreme, right? He's one of the richest individuals in the entire world. But that doesn't necessarily mean it's representative of all of the individuals within that group, where the median value was much more representative. Same idea goes here. Moving on to question number 4. Here's where we move forward from our measures of central tendency to now talking about the different types of distribution, whether they are negative, positive, or symmetrical, or normal. So starting off with our first example here. A study finds that most neighborhoods in a large city report low levels of violent crime per year, but a few neighborhoods have extremely high rates of violence. And so when thinking about these different distributions, I want you to think of where the tail would actually go and what direction are we being pulled. Again, thinking back to our PowerPoint, which direction is the skier going down the mountain? And so in this case, because we only have a couple extremely high rates of violence within some neighborhoods, we are being pulled in this direction. And so this is a positively skewed distribution. So most values are clustered at the lower end or lower crime, but a few neighborhoods have very high values or high crime, which creates a long right tail in the distribution. So again, this is an example of a positively skewed distribution. Next aspect here is a researcher analyzes the ages of which individuals in a juvenile justice program were first arrested. Most individuals were first arrested as teenagers, ages 13 to 17. The researchers decide to plot this on an x-axis continuum of 18 years, starting off with 0 to 18 years of age. And so again, thinking about what direction our tail goes. This time, because we have clustering at the higher end of our age range, which is mid to late teens, we still have some individuals that may have been arrested very early in life, but that's the direction our tail is pulling us. So it's a negatively skewed distribution. Lastly, we have that last component here where it states that researchers assess self-reported attitudes towards the police using a 5-point Likert scale, where 1 indicated very negative and 5 indicated very positive in terms of our perceptions. The distribution of responses yielded a mean, median, and mode value of 3, with relatively fewer individuals selecting the extreme values of 1 or 5. And so if we were to plot this out, again, this is merely an example. I didn't actually conduct a study here with any samples or anything of that nature, but to kind of think through what this distribution would look like. We know that our mean, median, and mode values here are all 3. And this is indicative of a normal distribution. If we have a perfect bell-shaped curve, our mean, median, and mode values should all be the same. So that is your clear indicator here that you should be looking at to know that this is a symmetrical or normal distribution. It also states, so another clue here is that we have relatively fewer individuals selecting our extreme values, and so it's going to tail off from our measures of central tendency, which are all located at our 3 value. So again, this is an example of a symmetrical or normal distribution. There is no significant skewness on either side, and so again, this is what is represented in terms of our normal distribution. If you have any questions about this particular problem set, I encourage you to reach out to me. This is something that is very applicable in your daily life when it comes to these measures of central tendency, of mean, median, and mode. One of the reasons I included this question about home values here is because this is a real life scenario that a lot of people run into. If you hear that the average home value of a certain neighborhood is $600,000, but it's being pulled by an extreme outlier value of a couple of houses, that's not necessarily representative of the neighborhood overall. And so this is very necessary for you to understand, not only for this class, but in everyday life. And these different measures are something that will keep reoccurring as we move forward with the duration of the semester. As always, if you have any questions, please feel free to email me or set up an appointment. Otherwise, I will see you in the next video.